Assalamu alaikum, everyone. In this video, we are going to discuss this paper, May, June 2022, paper 1, variant 2. This is the most recent paper that we had for A-level maths. Of course, the official marking scheme is not available yet. So if you do notice any careless error, make sure that you comment below. And also, if you're interested, you can find a lot of other recent solved past papers in the description. The playlist link is given there. You'll find paper 1, paper 3, paper 4 mechanics, and paper 5 S1 statistics. You'll find a lot of those papers for 2022 or for 2020 and 2021 solved there if you want to have a look at them. Now let's begin with this. Okay, let's start from the first question then. It's on binomial. It says the coefficient of x raised to power 4 in the expansion of 3 plus x whole raised to power 5 is equal to the coefficient of x squared in the expansion of 2x plus a over x whole raised to power 6. So basically, you've got to find the coefficients of these terms in these expansions and then equate them, and you'll find the value of the positive constant a from that. That's what you've got to figure out from there. Now, you could either use the term formula for this if you know about that. I generally prefer to just expand it using binomial formula. Most people find that much easier. So let's do that. Remember the binomial formula. It's given in the formula sheet. You can have a look at that if you forget about it. So this is where it is. It's given. It's given in a slightly different form here. N1 is as a bracket column vectors mein lakha hota hai. You can write it like this. You can say this as a plus b whole raised to power n, that equals a raised to power n plus nc1 a raised to power n minus 1 b raised to power 1 plus nc2 a raised to power n minus 2 b square, and so on all the way until you have b raised to power n. So what I'm going to do is I'm just going to expand these two things, 3 plus x whole raised to power 5, and find the coefficient of x raised to power 4 from that, and also the other one, find the coefficient of x raised to power 2 from that. Let's do that. So we've got 3 plus x whole raised to power 5 first. Now, 3 is supposed to be a here, x is supposed to be b here in the formula, and 5 is your n. So let's just input values in the formula. What do we get from this? We have 3 raised to power 5 plus 5c1 into 3 raised to power 4 into x raised to power 1. And then you have 5c2 into 3 raised to power 3 into x raised to power 2. And you can see you need the coefficient of x raised to power 4. What do we have until this point? We have x raised to power 1, then we have x raised to power 2. So we need to have 2 more terms, and then we'll get the x raised to power 4 term. We have 5c3 next into 3 raised to power 4 x cubed. And then finally, we've got the term that we need, that is 5c4 into 3 raised to power. So there's something wrong there. This should have been 3 raised to power 2 here. And this is 3 raised to power 1 into x raised to power 4. And that's the term that you need. You can just stop at this point. Ye aapko term chahiye. What's the coefficient of x raised to power 4 here? Let's evaluate that. 5c4, what does that give us? 5c4 is 5 into 3 into x raised to power 4. And that gives us 15x raised to power 4. So that's the term that you need from that first expansion. Now let's look at the other expansion. The other one is 2x plus a over x whole raised to power 6. Okay, again, if you look at the formula, this is supposed to be your a, this is supposed to be your b in the formula, and this 6 is your n. Let's just input values in the formula and see what we get. A, so that's 2x whole raised to power n, which is 6 plus 6c1 into 2x raised to power 5 into a over x whole raised to power 1. Okay, now you can just stop at this point because here you've got to think about this a bit, what terms you're getting exactly. So in the first case, you've got x raised to power 6, right? In the second case, you've got x raised to power 5 here and x raised to power 1 in the denominator. So that's x raised to power 5 minus 1, which is x raised to power 4. So the second term is x raised to power 4. What do we need here? We need x raised to power 2. So you can see the pattern. It's always constant difference as far as the powers are concerned. So the first term is x raised to power 6. The next one is x raised to power 4. The next one after that is going to be x raised to power 2. So we just need one more term, and the next term is 6c2 into 2x whole raised to power 4 into a over x whole raised to power 2. And you can see there, you've got x raised to power 4, you've got x squared in the denominator, that's x raised to power 4 minus 2, which is x squared, and that's the term you need. ये आपको term चाहिए. Let's evaluate the coefficient of x squared here. Let's do that. 6c2. So let's see what that turns out to be. Let me just find that out from my calculator. 6c2. Yeah, so that's 15. 15 into 2 raised to power 4, which is 16, into x raised to power 4 into a squared divided by x squared. Okay, if you simplify this, you get 16 into 15, that is 240 into a square x square. Now, these are the coefficients that you've got. You've got 240 a square here, and you had 15x raised to power 4 there. And they've basically told you that these coefficients are supposed to be equal to each other. So you say 240 a square is equal to 15. And you find the value of a from that. Let's see what we get from this. A square equals 15 over 240. Let's simplify this. 15 over 240, that gives you 1 over 16. You can do this cancellation here if you want. 1 over 16, take square root of that. You get a equals plus minus 1 over 4. Remember, whenever you take square root, you have plus minus, but let's have a look at the question. Yeah, so it says it's supposed to be a positive constant. A is supposed to be a positive constant. So that tells you you only have to consider the positive value here, and the value of a therefore turns out to be 1 over 4. So that's your answer to the first part, to the first question. All right, let's move on to the next one. Okay, so the second question. It says the second and third terms of a geometric progression are 10 and 8 respectively. Find the sum to infinity. Okay, again, these formulas are given in the formula sheet. Sum to infinity का formula आपके पास होता है formula sheet के अंदर. That's given like this: a over 1 minus r. So what do we need here? We need two things. We need the first term, and we need the common ratio. Once we have these two things, we can just input them in the formula, and we'll be able to find the sum to infinity. Now, how do you find those two things? So it's a GP. Let's write that information down here. It's a GP with the second term 10 and the third term 8. So you've got the second term here and you've got the third term here. You don't know the first term, which is supposed to be a. We'll figure out कर सकते हैं बाद में. But let's do it step by step. Okay, so you've got two consecutive terms given. You've got two consecutive terms given. You've got the second term and you've got the third term. What you can say is, since the ratio is equal in a geometric progression, the formula that we got for ratio is like this. Ratio is next term divided by the previous term. So you can find the ratio from this. You can say the ratio turns out to be the next term, that is 8, divided by the previous term, that is 10, 8 over 10. So ratio you can find directly from here, that is 4 over 5. Okay. Now the only thing that you need now is this value of a. What can we do for that? We can use the same thing for term 2 and term 1. So what we've done here essentially is we've said ratio equals T3 over T2, right? हमने T3 और T2 को divide कर दिया. You can do the same thing for T2 and T1. You can say term 2 and term 1, that should also give you the ratio. But now we've already have the ratio, and that is 4 over 5. Since we know the term 2 is 10, the term 1 is T1, that's equal to 4 over 5. We can find the value of T1 from here. So what do we get? We just cross multiply. It gives us 50 equals 4T1. And the term 1 turns out to be 12.5 from this. Term 1 is basically what you also represent by this letter A. So this is also your value of A. That's one way to do it. Of course, if you wanted, you could also use the term formula, and that would also work. You could say term 1 is equal to A, or in fact, you could say term 2 is equal to AR, and then you could, equate that with this. AR equals 10. Put the value of R here. You get the same result from that as well. The value of A will turn out to be 12.5. Okay, so you've got the value of A now. You've got the value of R. Sum to infinity formula is also there. Sum to infinity is equal to A, which is 12.5 divided by 1 minus R. 4 over 5 is essentially 0.8. You can also write it in decimals there. So that's 1 minus 0.8. Let's evaluate this and see what this turns out to be. It's 12.5 divided by 0.2, and that is 62.5. That's the sum to infinity that you've got. Okay, so that's the second question. Let's move on to the next one. Okay, so now we've got the equation of a curve that is such that dy over dx equals this thing, and it's given that the curve passes through the point 4 and 5 over 2, find the equation of the curve. So it's a pretty standard integration question. You've got the derivative, you've got to find the curve. What you do is you integrate the derivative. Okay, so dy over dx is given. Dy over dx is equal to 3 into 4x minus 7 whole raised to power 1 over 2 minus 4x raised to power minus 1 over 2. Let's integrate this thing. So what do you get when we integrate this? You see it's a linear expression inside, so you can just use the power rule directly. The number outside stays as it is, 3 stays as it is. Whatever is inside the power, that stays as it is. You increase the power by 1, 1 over 2 plus 1, that's going to give you 3 over 2, right? 1 over 2 plus 1, that's 3 over 2. And then you divide by this increased power. So you have increased the power by 1, and then you divide by this increased power. So you also divide by 3. And you also divide by the derivative of what is inside the power. So what's the derivative of 4x minus 7? The derivative of 4x is 4. 7 ka derivative is 0. So you get 4 in the denominator as well. Okay, now what about the integral of this thing? 4 is being multiplied, that stays as it is. Increase the power of x by 1, that is going to be 1 over 2, minus 1 over 2 plus 1, that's 1 over 2, and you divide by that increased power. Divide kar diya. X ka derivative is just 1. Even if you were to have it here, it will not make any difference. This is what we've got. But don't remember the plus c here, because whenever we integrate, we also have this constant of integration. Now, let's simplify this first. Let's simplify kar lete hain. Let's see what we get from this. 4 and 2 get cancelled. That gives us 2. This 2 here can go to the numerator and get multiplied by 4. Let's see what that gives us. So we've got 3. In fact, we can do one more cancellation here. This 3 and this 3, they can also get cancelled. So what do we have here? We've got 4x minus 7 whole raised to power 3 over 2 divided by 2 minus 8x raised to power 1 over 2 plus c. Okay, so now the problem is we need to find the value of c here. So for that, we are given this point. We are given that x equals 4 when y equals 5 over 2. एक point दिया हुआ है आपको, you just input that point here. You say, let's input 4 and 5 over 2 here. That means you input 4 in place of x and 5 over 2 in place of y and find the value of c from that. So you've got 5 over 2 equals 4 into 4 minus 7 whole raised to power 3 over 2 divided by 2 minus 8 into 4 raised to power 1 over 2 plus c. Let's evaluate this. On the left side, we've got 5 over 2. On the right side, we've got 16 minus 7, which is 9, 9 raised to power 3 over 2. I think that should be 27. Let me just confirm that. Yeah, so that's 27. 27 over 2 minus 8 into 2, which is 16 plus c. You can find the value of c from here and see what you get. 5 divided by 2 minus 27 divided by 2 plus 16. The value of c turns out to be 5 here. And now you can finally write down your final result. Your equation is y equals 4x minus 7 whole raised to power 3 over 2 divided by 2 minus 8x raised to power 1 over 2. And in place of c there, you can write 5 now. That's the equation of the curve that you were looking for. Okay, so that's the final result. That was question number 3. Let's move on to the next one. Okay, so now it's again an AP-GP question, but now we've got an arithmetic progression. And in an earlier question, we had GP, but now we've got an AP. So it says the first, second, okay, so it says the first, second, and third terms of an AP are k, 6k, and k plus 6. We need to find the value of the constant k. All right, so it's an AP, remember? In an AP, the difference between the terms is constant. So the first term is k, the second term is 6k, and the third term is k plus 6. Now, since the difference is supposed to be constant, that means we could find difference, multiple ways. You could say difference is the same thing. Difference is equal to term 2 minus term 1, right? And the difference is also equal to term 3 minus term 2, right? The difference is supposed to be constant. So what we can do is we can subtract the first and second terms. So that gives us 6k minus k. And we can also subtract the second and third terms. That's going to give us k plus 6 minus 6k. That's a linear equation. We can just solve that and find the value of k from that. So let's see what we get. 5k equals minus 5k equals 6. 10k is going to be equal to 6, and k turns out to be 6 over 10, which is 3 over 5. So you solve this, you'll find the value of k to be 3 over 5 from that. All right. Okay, let's move on to part 2. Part B. Now it says find the sum of the first 30 terms of the progression. Okay. Now remember the sum formula for an AP. So you've got two formulas given in the formula sheet. One of them is n over 2 into 2a plus n minus 1 times the difference. The second formula needs you to have the last term given, but you don't have the last term formula. What do we need for this? We need the value of n. We know that, that's 30. We need the first term. The first term is there as well. The first term is k. And we need the difference. Difference, we can figure that out. The difference is, 6k minus k. You've got the difference as well. Okay, so you've got everything that you need. You just input that in the formula. But let's evaluate those things separately because right now they're in terms of k. So let's input the values of k there and evaluate those things. The first term a is supposed to be k. We already have the value of k. We can just input that there. Okay, sorry about that. Yeah, so we already have the value of k. We can input that there. That is 3 over 5. So a turns out to be 3 over 5. Okay. Achha. Then we need the difference. Difference, we can say this is this difference, 6k minus k. That gives you 5k. And what's that? That is 5 into 3 over 5, and that is 3. So you've got the first term now, and you've got the difference now. You can just input these values in the formula for sum of an AP. S30 is equal to 30 over 2 multiplied by 2 into the first term, that is 2 into 3 over 5, plus n minus 1, that's 30 minus 1, which is 29, times the difference into 3. Let's evaluate this. Outside, we've got 15, 30 over 2. And inside, we've got 6 over 5 plus 29 into 3. And that turns out to be, no, so there's something wrong here. Yeah, so 6 over 5 plus 29 into 3. So I'm getting 441 divided by 5 inside. And now we can evaluate this by multiplying this number by 15. And that turns out to be 1323. So the sum to infinity, sum of the first 30 terms is equal to 1323 from this. All right. So that was the second part. Let's move on to the next one. Okay, so we've got question number 5 next. Let's have a look at this. So it says the equation of a curve is y equals kx plus 1 over 2 k square, and the equation of a line is y equals x minus a. So we've got a curve and we've got a line where k and a are constants. It says given that the curve and the line intersect at the points with x coordinates 0 and 3 over 5, find the values of k and a. All right. So what do we have here? We've got the points of intersection of those two graphs. Now, how do you find points of intersection? So we've got a curve. The curve is y equals 4x squared minus kx plus 1 over 2 k squared. And we've got a line, and the line is y equals x minus a. How do you find points of intersection of two graphs? You basically find them by equating the two graphs, equating the two equations. So we've got y equals this, and we've got y equals this. We can just equate those two equations. That gives us 4x squared minus kx plus 1 over 2 k square, and that equals x minus a. So basically, what we're given is that the solution of this equation is either this, or you can say these two values are the solutions of this equation, right? Because we are given the points of intersection. How do we find points of intersection? We find points of intersection by equating these equations, right? So we've done that. So that means the solutions of this equation are supposed to be 0 and 3 over 4. So what does that mean? This equation should satisfy both of those values. So it should satisfy x equals 0. So when x equals 0, this equation should satisfy. And also when x equals 3 over 4, this equation should also satisfy. So what we can do is we can just input x equals 0 here once, and that's going to give us an equation in terms of k and a. So let's do that. 4 into 0 square minus k into 0 plus 1 over 2k square equals 0 minus a. So we've got one equation in terms of k and a here. Let's simplify this. We basically have 1 over 2k square equals minus a from this, and k square equals minus 2 times a. Okay, so that's a relationship between k and a that we get from this. Let's look at the other value of x. The other value of x that we're given is 3 over 4. So that should also satisfy this equation. Let's input that here. X equals, okay, what happened there? Yeah, so x equals 3 over 4. That should also satisfy this equation. Let's input that here. What do we get from that? We have 4 into 3 over 4 squared minus k into 3 over 4 plus 1 over 2 k squared. That equals 3 over 4 minus a. Okay, so we've got two equations, and now we can just solve them simultaneously. So what do we have here on the left side? We have 4 into 3 squared divided by 4 squared. Let's evaluate that. That should be 9 over 4, I think. 9 over 4 minus 3k over 4 plus 1 over 2k square. That equals 3 over 4 minus a. Now, what we can do here is we can just input the value of k squared there, or you can input the value of a there. That's easier, actually. Let's make a the subject. A equals minus k square over 2. Let's input that thing here. Let's input this in the other equation. Let's see what we get from that. So we have 9 over 4 on the left side minus 3k over 4 plus 1 over 2k square. That equals 3 over 4 minus a. So that becomes plus k square over 2. Okay, so now we've got this equation. It's a quadratic equation, but what helps us here is that this k square 2 and this k square 2, they're going to get cancelled. Why? Because they're both equal. एक दूसरे पे जाके minus हो जाएगा. They get cancelled, and we are left with 9 over 4 minus 3k over 4 equals 3 over 4 only. Now we've got 4 in the denominator. We can just multiply the whole equation by 4, and that gives us 9 minus 3k equals 3, and 3k equals 6, and k turns out to be equal to 2 here. So we've got the value of k. Now let's input this value of k back in the first equation. What do we get from that? We have a equals minus into 2 whole squared divided by 2. And that gives us a equals minus 4 over 2, which is equal to minus 2. So we've got the value of a here, that is also negative 2. Okay, so we've got the value of a and k. That's what we needed. A equals minus 2 and k equals 2 there. All right, let's move on to the next part. Now the next part says given instead that a equals minus 7 over 2. Okay, so it says given instead. That means the first part is not relevant anymore. And the first part, they said that the values of the points of intersection are supposed to be 0 and 3 over 4. That's no longer relevant. That does not apply to the next part now. It says given instead that a equals minus 7 over 2. So let's see what information we had in the question itself. In the question statement, we were just given the equation of the curve. and equation of the line. Let's use that here. We have y equals 4x square minus kx plus 1 over 2 k square, and we have y equals x minus a, right? So anything else from the first part is not relevant. This is the only thing that's relevant for us in the second part. Now it says the value of a is equal to minus 7 over 2. We have to find the values of k for which the line is a tangent to the curve. Now, what does that remind you about? Line is a tangent to the curve. That basically means your discriminant, it's going to be a quadratic equation. In quadratic equation, if a line is a tangent to the curve, that means b squared minus 4ac is equal to 0. Line being tangent to the curve, that means there's only going to be one solution of that equation that you get, and that means b squared minus 4ac, the discriminant should be equal to 0. Okay, so now we are given the value of a. Let's input that here first. Y equals x minus a, that means x plus 7 over 2. When we input the value of a to be minus 7 over 2 there, y equals x plus 7 over 2. And now we will just equate these two equations because we already have y the subject in both of them. And then we will find discriminant, put that equal to 0, and then solve that to find the values of k. All right, so let's do that. Let's equate these two equations. We get 4x square minus kx plus 1 over 2k square. That equals x plus 7 over 2. Now, before we can use the discriminant, we need our equation to be in that form, ax square plus bx plus c equals 0. That means we want all the terms, all the non-zero terms on the left side and only 0 on the right side. So let's do that. Let's take everything to the left side and see what that gives us. So we've got 4x square minus kx minus x plus 1 over 2 k square minus 7 over 2. All right. Now, just for our ease, we can just multiply this whole equation by 2 so that we get rid of the fraction. Let's see what that gives us. We've got 8x square minus 2kx minus 2x plus k square minus 7 equals 0. Okay, it was just to get rid of the fraction. Now, let's look at the coefficient of x squared. The coefficient of x squared is 8. What about the coefficient of x? We'll have to take x common for that. So we can say this is minus into 2k plus 2 into x. And we've got the constant term. The constant term is basically any term that does not have an x in it. So that is k squared minus 7. And that equals 0. Okay. Now, what's the value of a here? A is 8. B is minus into 2k plus 2. And c is k squared minus 7. So what we want now is we want to put the discriminant, that's b squared minus 4ac equal to 0. Let's input values in this. We've got minus into 2k plus 2 whole squared minus 4 into 8 into k squared minus 7, that equals 0. Right, so we've just compared it with this form, ax squared plus bx plus c. We've got the values of a, b, and c. And then we're just inputting them in the discriminant and putting that discriminant equal to 0. And let's solve this now. This is negative sign. If you were to square that, the negative sign is going to become positive. So we don't really care about that. We are just left with 2k plus 2 whole squared. Okay. And here we've got 4 into 8, that is 32 into k squared minus 7. Let's simplify this. 2k plus 2 whole squared. So we are using a plus b whole squared here. 2k whole squared, that is 4k squared, plus 2 into 2k into 2, that is 8k plus 4 minus 32k squared plus 32 times 7. Let's evaluate that. That turns out to be 224. And this is equal to 0. Okay, so let's simplify. We have 4k squared minus 32k squared, that is minus 28k squared plus 8k and plus 228 equals 0. We can simplify this a bit because I think all of them are divisible by 4. Yeah, so let's do that. Let's divide everything by 4, and that's going to give us 7k squared here and 2k plus 228 divided by 4, that is 57. Okay, I'm just going to multiply this by negative. I'm just more comfortable having the first term positive. 7k squared minus 2k minus 57 that equals 0. All right, so now we can see whether we can factorize this or we have to use the quadratic formula. It's your choice. If you can't think of factors, in this case, it's difficult to think of the factors because it's large numbers. So even if it can be factorized, you can just, what you can do is you can just input values in the form in the quadratic formula. Let's do that. We have k equals minus into -2 plus minus square root of b, which is -2 whole square minus 4 into 7 into -57 divided by 2 into 7. And once you've input values in the formula, now if you want, you can just write down answers directly from your calculator, and that will be okay. But this step is necessary. You have to show the step, especially in paper 1, otherwise you're going to lose marks. So once you've shown this step, once you've input values in the formula, after that, you can just write answers directly. So I'm just going to use the equation function on my calculator to evaluate this directly. Let's see what we get from this. It's a polynomial, degree 2. The first term is 7, then we have -2 and -57. Okay, so I'm getting k equals 3 here. That's one value that I'm getting. And then the second value is -19/7. Let's see if there was any restriction on the values of k. So it says values of k. That means you were supposed to have multiple answers. We have multiple answers here, and that should be okay. So k equals 3 and k equals -19/7. That's your final result in this part. Okay. So that was part B here. All right, let's move on. Next, we've got question number 6 here. The diagram shows the curve with equation y equals 5x raised to power 1/2, and the line with equation y equals 2x plus 2. All right, so we've got these two graphs. It says find the exact area of the shaded region, which is bounded by the line and the curve. Okay, so this is basically the shaded region, this region here. We've got to find the area of the shaded region. Let's see what we can do about this. Remember, we've got the formula for that. Area between a curve and the x-axis. The formula that we've got for that is integral of y with respect to x. The limits are from a to b, whatever those limits are. So in this case, we've got this limit here and this limit here. Okay, so the first problem that we've got now is we've got to find the limits that we're going to input here. So we've got to find the values of x for these points of intersection. How do you find the points of intersection? We just equate those two graphs, equate those two equations, and solve them simultaneously. Let's do that first because we need the limits. We have y equals 5x raised to power 1/2. That's the equation of the curve. And we've got y equals 2x plus 2. Okay, we have to find the points of intersection of these two graphs. We equate them. We have 5x raised to power 1/2. That equals 2x plus 2. Okay, so one way to do this would be, since the powers are in the ratio 2:1, right? This is 1/2. This power is 1/2. This power is 1. We can use a substitution here. We can say, let some other variable, let's say m equals x raised to power 1/2. So whatever is the smaller power, you substitute that with another letter. And this equation is going to become 5m equals 2m squared plus 2. So that's a quadratic equation. We can solve this. 2m squared minus 5m plus 2 equals 0. Let's see if we can factorize this. So we can use 4m minus m plus 2 equals 0 here. And then 2m into m minus 2 minus 1 into m minus 2 equals 0. And that gives us 2m minus 1 into m minus 2 equals 0. And m equals either 1/2 or 2. Okay, we've got two values of m, but now we replace that back. We have x raised to power 1/2 that equals 1/2, or x raised to power 1/2 equals 2. Okay, so we square both sides. We have x equals 1/4, or we've got x equals 4. So these are the limits that we have here. Limits for the integral that we're going to use there. This is 1/4 and this is 4. All right, so that's the first thing that we had to do here. We had to find the limits. Okay, now we've got to find the area. So what can we do for this? We have an upper curve. So we've got this shaded region, and this shaded region is bounded by two graphs, right? By two graphs. We've got the upper graph. What's the upper graph? This is the upper graph. The equation of that upper graph is y equals 5x raised to power 1/2. And in that shaded region, for that shaded region, the lower graph is the straight line. What's the equation that we've got for this? We have y equals 2x plus 2. All right, so equation of the line is y equals 2x plus 2. So what we have to do is we have to subtract the area under the upper curve. So we have to do this subtraction, area under the upper curve minus area under the lower curve. Okay, so we have to subtract area under the lower curve from the area under the upper curve. That's what we're going to do here. All right, let's do that on the side here. So we have two integrals. We can just, we have to use this formula, remember. Kya karenge? We say the shaded region, the shaded area, that is equal to area under the upper curve minus the area under the lower curve. In fact, the lower graph is not a curve. We can say area under the upper graph minus area under the lower graph. Now, since the limits are the same here for both of them, we can actually just combine them. We can do the subtraction first and then integrate. So I'm going to do it that way. I'm just going to subtract them first. So upper graph is 5x raised to power 1/2. So that's 5x raised to power 1/2. Subtract from that 2x plus 2. That's the lower graph. And then just integrate both of them together with respect to x with limits 1/4 to 4. Okay, we can do that separately if you want. We can also do it together like this. That's your choice. But I'm gonna do it this way. Let's see what we get from this. Let's simplify what we have inside the integral first. We have 5x raised to power 1/2 minus 2x minus 2. This is the integral. Let's find the integral. This is going to be 5x raised to power 1/2 plus 1, which is 5x raised to power 3/2 divided by 3/2. Subtract from that 2x. The integral of 2x is 2x squared. Increase the power of x by 1. Divide by that increased power. So that's 2x squared over 2 minus 2 times x. And we've got the limits. Limits are from 1/4 to 4. Okay, let's simplify this first before we input the limits. That's going to make your calculation a bit easier. This 2 is going to go up in the numerator, and that gives us 10x raised to power 3/2 divided by 3 minus x squared minus 2x. Now let's input the limits. This step is necessary that you show how you're inputting the limits. So let's substitute the limits inside. Don't do this directly on your calculator. You have to input, you have to show this process. 10 into 4 raised to power 3/2 divided by 3 minus 4 squared minus 2 into 4. So that's what happens when you input 4. Now let's subtract from this the case when we input 1/4. So we have 10 into 1/4 raised to power 3/2 minus divided by 3 minus 4 minus 1/4 whole squared minus 2 into 1/4. So this is what we have to evaluate here. Let's evaluate both brackets one by one. So for the first bracket, we've got 10 into 4 raised to power 3/2. That's going to be 1. That's going to be 8. Okay, 10 into 8 divided by 3 minus 16 minus 8. So we have 8/3 from the first bracket. Subtract from that the result from the second bracket. Let's see what we have from there. 10 divided by 8 and then divided by 3 minus 1/16 minus 1/2. Yep, So I'm getting minus 7 over 48 from this. Let's evaluate this further and see what we get. 8 divided by 3 plus 7 over 48, and that gives me 45 over 16. So that's the area that we're getting. That's the shaded region, area of the shaded region. We can leave it like this if we want, or if we want to write it in decimals, we can write it in decimals as well. And that is going to be 2.8125, which is 2.81 to 3 significant figures, and that's also fine. That's the area of the shaded region. No. So you can't do that. It says exact area. So you can't write in decimals. You will just leave it at this point. Sorry about that. I'll actually say this is 45 over 16. That's your final result because we needed exact area. You can't have decimals there. All right. So the exact area is 45 over 16. That's what we had to do in this question. This was question number 6 in this paper. Okay, let's move on. Let's move on to question number 6. This is the next one. This looks like circle layer. Okay, so the diagram shows a sector OBAC. Okay, so the diagram shows a sector OBAC. Okay, of a circle with center O. So this is the center and radius 10 centimeters. The point P lies on OC and BP is perpendicular to OC. Okay, the angle AOC is pi over 6. We've got this angle given. And the length of the arc AB is 2 centimeters. So this arc here, just this part, this is 2 centimeters. Okay, we have to first find the angle BOC. BOC, that's this whole angle. We have to find this whole angle. All right, so the statement here just describes what you have in the diagram. आपको सब कुछ diagram पे नजर आ रहा है already, so there isn't really much that you need to worry about there. Let's find this angle BOC. Now you see, you already have one part of this angle. This part is already known. All you need to do is you need to find this remaining part, and then you can add pi over 6 to that, right? How do you find this remaining part? You're given arc length. You're given arc length for that part. So you can use the formula S equals R theta. Let's do that. S equals R theta. That's the arc length formula. We know the arc length is 2. The radius is also known. That's 10 into theta. And that's going to give us the value of theta there. So that is 2 over 10, which is 0.2. That's 0.2 radians. Okay. What about the angle BOC then? This total angle. The total angle is going to be 0.2 plus pi over 6. Let's see what that turns out to be. Angle BOC. That is pi over 6 plus 0.2. And that's going to give us a result. Okay, so pi divided by 2 plus 0.2. And that is giving me 1.7. No, so pi over 2 मैंने कर दिया यहाँ पे. It should be pi over 6. Yeah, so that's giving me 0.7236. You can leave it like this if you want, because there's no instruction in the question itself, or if you want, you can round it off to 7.724 if you want. That's the angle that you were looking for. Okay, let's look at the next part. Now it says, hence find the area of the shaded region BPC. Okay, okay, so I can't really see a shaded region here. Let me just see what that is. BPC. Okay, so the shaded region will basically be this part here. Let me shade that. Yeah. So basically, this is the shaded region. We've got to find the area of this region. Okay, so you need to find the area of the shaded region. So what we can do is we can just have a look at, we can describe this area first. So basically, this area represents area of sector, area of this complete figure, minus area of this triangle, right? So we just find the area of the sector and subtract from that area of the triangle. Let's do that. So what we can do for that is we can use the area of sector formula first. So we have shaded area that is equal to area of the sector minus area of the triangle. What about the area of the sector? We've got the formula for that. That's half r squared theta. What's the radius? The radius is 10. So that's 10 squared into theta. Angle of the sector, that's what we found in the first part, 0.724. We will use the more accurate number. That's 0.7236. Okay, so that's the area of the sector. We subtract from this area of the triangle. Now, let's see if we can find the area of the triangle from this. We have this length, we've got this angle, but we don't have any other information. Okay, so we need to figure out a way to find the area of the triangle first. What we can do is, we can first find, so it's right angle triangle, and we know this complete angle. We know this angle is 0.7236. Remember it's in radians, so your calculator should be in correct mode. So this is 0.7236 radians, and we know this hypotenuse, right? What we can do is, we can find this length here. Okay, we can find the length OP. Let's do that. OP and OB. OP is the base, and 10 OB is your hypotenuse. Base or hypotenuse में क्या ratio होती है आपके पास? You've got cos there. You can say cos of, let me do that on the side here, cos of 0.7236. That should equal base, which is OP, divided by the hypotenuse, that's 10. Let's find out the value of OP here. Your calculator has to be in radian mode. Keep that in mind. Okay, let me do that. 10 into cos of 0.7236, and that's giving me 7.494. So that's the length OP. So once I have this length, I can use half AB sine C formula, because now I've got this length. This is 7.494. I've got this length, and I've got the angle between these two lengths. I can use half AB sine C formula here for the area of the triangle. Let's see what that gives me. So this is 1/2 into A, which is 10, into B, the second length, that is 7.494, into sine of the angle between them, which is going to be sine of 0.7236. And let's just evaluate this and see what we get. 100/2 into 0.7236. That gives me 36.18. It's a good idea to write down these numbers separately, because even if you end up doing an error, you will get some partial marks if you do this correctly. If the final answer turns out to be incorrect because of some careless error, you will get more partial marks if you write down these numbers here. Okay. So the second one gives us 1/2 into 10 into 7.494 into sine of 0.7236, and that's giving me 24.81. Let's evaluate this. Let's subtract these two numbers. We have 36.18 minus the answer, that is 11.37. So it says we have to give our answer correct to 3 significant figures, so it's necessary to round it off here. Otherwise, we're going to get an incorrect result. So this is 11.4, and that's the area of the shaded region that we were looking for. Okay, so that was part B here. Okay, so next we have question number 8. It says the equation of a circle is x squared plus y squared plus cx plus by minus 12 equals 0. There are 2 points A and B that lie on the circle. Find the values of A and B, and hence find the coordinates of the center of the circle. Okay, so if these points lie on the circle, that means they should satisfy the equation of the circle. So let's just input those points here in the equation: x squared plus y squared plus ax plus by minus 12 equals 0. Let's input the first point, that is point A, which is 1 and 1. And let's then also input the second point, which is 2 and minus 6. Okay, so when we input 1 and 1, we get 1 squared plus 1 squared plus A into 1 plus B into 1 minus 12 equals 0. And that gives us 1 plus 1 minus 12, that's minus 10. That's a plus b minus 10 equals 0, and a plus b equals 10. So that's one equation that we've got. Then we input 2 and minus 6. Let's see what we get from that. X equals 2, so that's 2 squared plus minus 6 squared plus a into 2 plus b into minus 6 minus 12 equals 0. That gives us 4 plus 36 plus 2a minus 6b minus 12 equals 0. And that is 2a minus 6b. 40 minus 12, which is 28 equals 0. And that is a minus 3b plus 14, or that becomes minus 14. That's your second equation. We've got the two equations. Now you can solve them simultaneously. Again, it's necessary to show the process for this. It's paper 1. You have to show how to solve simultaneous equations here. You can either use substitution or you can use elimination, whatever you are comfortable with. I can make a the subject in both of them. That gives me 10 minus b here. And here it gives me minus 14 plus 3b. Okay, so now we have a as the subject in both of them. What we can do is we can just equate both of them, and that gives us 10 minus b equals minus 14 plus 3b. And that is going to be minus 4b equals minus 24. And b equals 6 from this. So once we have the value of b, we can input that in the first equation there and find the corresponding value of a as well. A is going to be 10 minus 6, which is 4. Okay, so you got the values of a and b now. Now that's one thing that we had to do here. The second thing that they've asked about is that we have to find the coordinates of the center of the circle as well. Let's do that. Let's find the coordinates of the center of the circle. For that, we just input these values of a and b back in the equation first. That's ax plus by, which is going to be 4x plus 6y minus 12 equals 0. How do you find the coordinates of the center of the circle? You basically complete the square. So for that, we write the x terms together, x squared plus 4x. We leave some space, and then we have y squared plus 6y. And we can take 12 to the other side if you want. We've got 12 there. Now, let's complete the square for the x terms. 4 divided by 2, that's 2. So we have 2 squared here, and then minus 2 squared here to balance that. And similarly here, 6 halved is 3. So that's 3 squared minus 3 squared. These first 3 terms here are going to give us a perfect square. And similarly, these 3 terms are going to give us a perfect square. Let's see what that gives us. That's x plus 2 whole squared minus 4. That's this one outside. And we have y plus 3 whole squared minus 9 equals 12. You can take the constants to the other side, x plus 2 whole square plus y plus 3 whole squared equals 12 plus 9 plus 4. That's going to be 25. Now remember, what's the standard form of the equation of a straight line? This is it's x minus a whole square plus y minus b whole square equals r square. We compare with that and we figure out the coordinates of the center of the circle are going to be minus 2 and minus 3. These are the coordinates. Basically, you can just flip the numbers inside the bracket. This is plus 2. Flip the sign, that's minus 2. It's going to be minus 2 there. This is plus 3, flip the sign, that's going to be minus 3, and that's the center of the circle. Okay, radius would be 5, but we're not really required to find that. If you wanted, you could just write that the radius is also 5 there. Okay, let's move on. Part B. Part B says find the equation of the tangent to the circle at the point A, giving our answer in the form of this, where P, Q, and K are integers. So we have to find the equation of the tangent to the circle. Now, let's just try to think about this. This is the circle. We've got the center of the circle. We've got the coordinates of the center. The coordinates of the center are minus 2 and minus 3. We've got some point A on the circumference. The point A is 1, 1. So let's say that's somewhere here. The coordinates are 1 and 1. We need to find the equation of the tangent to the circle. Now remember, in a circle, tangent and radius, they are perpendicular to each other. So we could just find the radius of the gradient of this radius, and then take the negative reciprocal of that to find the gradient of the tangent. Remember, in order to find the equation of a straight line, we need two things. We need the gradient of the line and we need a point on the line. We already have a point on the line, right? This is the point that's given. How do you find the gradient? You can find the gradient of the radius. Let's do that. I'm going to do that here. Let me call this point O, the center of the circle. I can say the gradient of OA is going to be 1 minus 3, that's 1 plus 3, divided by 1 minus 2, that's 1 plus 2, and that gives me 4 over 3. That's the gradient of the radius. What about the gradient of the tangent then? Tangent is negative reciprocal of this. Because it's perpendicular, so gradient is going to be negative reciprocal. That turns out to be minus, change the sign and take reciprocal, that's going to be 3 over 4. So we've got the gradient, we've got a point that lies on the line, which is the point A, that's 1 and 1. We can write down the equation of the line now. We've got this form, y minus y1 equals m into x minus x1, and that gives me y minus 1 equals minus 3 over 4 into x minus 1. Let's simplify. You need the x and y terms on the left side and the constant on the right side. And this gives us 4y minus 4. That equals minus 3x plus 3. Let's take the x terms to the left side. X and y terms to the left side, 3x plus 4y. Take the constant to the right side, and that's going to be 7 on the right side. So we have 3x plus 4y equals 7. That's the equation of the tangent that we were looking for. That's part B here. Okay. Question number 9. The equation of a curve is y equals 3x plus 1 minus 4 into 3x plus 1 whole raised by 1 over 2 for x greater than minus 1 over 3. So this is an equation that we're given, and we have to find dy over dx and dy over dx squared. So the first derivative and the second derivative. Let's figure that out. Dy over dx. So we have 3x, the derivative of 3x is 3. The derivative of 1 is just 0. We can skip that. And then we have minus 4 into 1 over 2. So we multiply by the power, subtract 1 from the power. So that's going to be 3x plus 1 whole raised to power 1 over 2 minus 1. That's minus 1 over 2. And then multiply with the derivative of what is inside the brackets. That's 3. That's your first derivative. Okay, we can simplify this. If we simplify this, we get 3 minus, this gets cancelled. You have 2 here, 2 times 3, that's 6. So we have 3 minus 6 into 3x plus 1 whole raised to power minus 1 over 2. That's your first derivative. So that's one thing that we have to figure out. Then we have to find the second derivative. That's d2y over dx squared. The derivative of 3 is 0. And then we have minus 6 into the power, that is minus 1 over 2, into 3x plus 1 whole raised to power minus 1 over 2 minus 1, which is minus 3 over 2. And then we multiply by the derivative of what is inside the brackets. That's going to be 3. Again, we simplify this. And we see what we get from that. 2 and minus 6. 2 and 6, they get cancelled. We have 3 here. We've got 1, 2 negative signs. So it's going to become positive. 3 times 3, that's 9. And we have 9 into 3x plus 1 whole raised to power minus 3 over 2. That's your second derivative. Okay, so that's what we had to do here. We had to find the first derivative and the second derivative. Part B, it says find the coordinates of the stationary point of the curve and determine its nature. Okay, so we have already found the first derivative. How do you find stationary point? At stationary points, the derivative is equal to 0, or you can say, since the gradient is 0, that's why the derivative is 0. So whatever derivative we found there, we can just put that equal to 0. So we've got this 3 minus 6 into 3x plus 1 whole raised to power minus 1 over 2. We put this equal to 0. All right. Now let's try to solve this. We have 3 equal to 6 into 3x plus 1 whole raised to power minus 1 over 2. We can take this to the denominator and make the power positive. So that's going to be 6 over 3x plus 1 whole raised to power 1 over 2. Now we can take this to the other side, and that gives us 3 into 3x plus 1 whole raised to power 1 over 2. That equals 6. In fact, we could just cancel this out as well. This is 3. We could take that 3 to the other side, and it would get cancelled with 6, and we will be left with 2 at the end. So we've got 2 here on the right side, right? So because you can just cancel them out, we've got 2 here. Okay, now since we have got 1 over 2 power, we can just square both sides to get rid of that power. That's going to give us 3x plus 1 equals 2 squared, which is 4. And then we have 3x equals 3 and x equals 1. So we've got the value of x here. That's 1. It says coordinates of the stationary point. That means you also need the y coordinate. So how do you find the y coordinate? We've got the equation of the curve given, and the equation of the curve is 3x plus 1. Let's write that down here. Y equals 3x plus 1. And then we have minus 4 into 3x plus 1 whole raised to power 1 over 2. Okay, so that's your equation. We can put the value of x, that's 1 here in this equation, and see what we get from this. We have y equals 3 into 1 plus 1 minus 4 into 3 into 1 plus 1 raised to power 1 over 2. And that gives us 3 plus 1 minus 4. 4 raised to power 1 over 2, that's going to be 2. And we get minus 4 from this. So the y coordinate is going to be minus 4. The coordinates of the stationary point, therefore, are 1 and minus 4. So that's one thing that we have to figure out here, the coordinates of the stationary point. And the second thing is we've got to determine its nature. How do you determine the nature of a stationary point? You basically find the second derivative. So we already have the second derivative found earlier as well. Let me just write that here. The second derivative was 9 into 3x plus 1 whole raised to power minus 3 over 2. That's the second derivative. Now we can put the value of x here. The value of x is 1. Let's input that here. We get 9 into 3 plus 1 raised to power minus 3 over 2. And that gives us 9 into 4 raised to power minus 3 over 2. And we can take that, or we can just evaluate this directly from our calculator. 9 over 4 raised to power 3 over 2. 4 raised to power 3 over 2 is basically 8. So that's something positive. All we are interested in is that whether this value is positive or negative. Since this turns out to be positive, we say the stationary point that we've got, that's a minimum point. Okay, second derivative negative means that the stationary point is a minimum point, and that's what you have to figure out. So we've got the coordinates of the stationary point and the nature of that point as well. All right. Okay, so that was question number 9. Let's move on to question number 10 now. So now we've got functions. It says f of x equals 2x plus 1 divided by 2x minus 1. And the domain of this function is that x is not equal to 1 over 2. And we got another function g of x, and that is defined for all values, for all real values of x. Okay, we also have some graph here. This diagram shows part of the graph of y equals f of x. Okay, so this is the graph of this function, f of x. And we need to find the domain of f inverse. Okay, and it's just a 1-mark question. Let's think about this. So we've got the function f of x. We have to find the domain of f inverse. Now remember, domain of the inverse function, that's basically the same as the range of the original function. So domain of f inverse is basically going to be the same as the range of f of x. Range means the y values of the original function. So if you look at the original function f of x, you've got the graph for that here as well. You can see it's basically, it's going above here. So there's no upper limit. Similarly, it's going down here. There's no lower limit. So it's basically going everywhere from negative infinity to positive infinity. There's basically no end on both sides, right? So it's continuing on both sides. But however, since the graph is broken, there is one point at which it's not defined. And it's given there as well. On the x-axis, it's not defined when x is equal to 1/2, right? So this for this value of x, this is not defined. And there's also one value of y for which this is, there's also one value of y that we do not get on this graph. And that's basically this value. So the graph is never really getting to this value. And what is this value? This is 0, 1, 2. So this is supposed to be 1. So the graph is either above this line, right? It's never really intersecting this line or touching this line. Similarly, the other option is the graph is below this line. So what you understand from that is the graph can have any value of y except this value, that is 1. So what do we understand about the range of the function f of x from this? We understand that the range of f of x could basically be either greater than 1 or less than 1. That's one way to write it. Or in other words, you can also say y could be any real value. So because it's going from negative infinity to positive infinity, it could be any real value, except there's one exception, and that is that y cannot be equal to 1. So it cannot be equal to 1, but apart from that, it can take any value on the number line. Okay. Now, if this is the range of f of x, what that means about the domain of f inverse is it's going to be exactly the same. It's just that here we've got y. For the domain, we will use x here. Let's say it's x greater than 1 or x less than 1. We can have an or between them. This is one way to write that. Another way to write this is, you could say x could be any real number. However, there is a restriction, and that is that x cannot be equal to 1. So you could write it like this, that's correct, or you could write it like this is also correct. So you could write it both ways. Okay, so that's the domain of f inverse. You could say this, or you could say this. Okay, let's move on to the next part. It says find an expression for f inverse of x. So now we've got to find the inverse expression for the inverse function. F of x is equal to 2x plus 1 divided by 2x minus 1. That's what the function is. And we're also given that x cannot be equal to 1/2. Right? The reason for that is that we will get 0 in the denominator, right? So that it cannot be 1/2. All right. Now, how do you find the inverse function? You basically start from this. You say let y equals f of x. So replace f of x with y, and that gives you y equals 2x plus 1 divided by 2x minus 1. Now you make x the subject. You can just multiply this thing on the other side first. Let's see what we get from this. We have 2xy minus y, that equals 2x plus 1. Let's take all x terms to the left side, and that's going to give us 2xy minus 2x equals y plus 1. Now let's take x common from here, and we get 2y minus 2, that equals y plus 1, and x equals y plus 1 divided by 2y minus 2. So what do we get from this now? We just replace x with f inverse of x here, and f inverse of x equals x plus 1 divided by 2x minus 2. That's the inverse function. That's what we were looking for. This is your inverse function. Okay. All right, let's move on to the next one now. Now, in the next part, we are asked to find GF inverse of 3. Okay. Now, there are two ways of thinking about this. One possibility is that you find GF inverse of x. You could find this function. And then once you have that function, you input 3 into that. That's going to be slightly longer. An easier way to think about this is just do it step by step. You evaluate this thing first. You evaluate f inverse of 3. Okay, let's do that. Let's evaluate f inverse of 3. F inverse of 3, what is that going to be? We just input 3 in this function. So we get 3 plus 1 divided by 2 into 3 minus 2. Okay, And that gives us 4/4, and that's equal to 1. So basically, f inverse of 3 is equal to 1. And now we put this value inside the function g, right? Because g f inverse of 3, that basically is the same thing as saying g of f inverse of 3, that you input this value inside the g function. Now, what's this value? We already found that here. That's basically 1. So we are looking for g of 1 essentially. Okay. So we look at the function g. G function is right here. Yeah, x squared plus 4. We put the value of x equal to 1 in that, and we evaluate this. So what do we get? We have x squared plus 4. Let me just write that here on the side. G of x function. G of x function is x squared plus 4. What do we get? We have 1 squared plus 4, and this gives us 5 as our final result. Okay, so that was part C here. Let's move on to the next one. Now the next part says, explain why g inverse of x cannot be found. Okay, so this is the function g. This is the function g, x squared plus 4, and it's defined for all real values of r, all real values of x. Let me just write that function here first. So that's g of x equals x squared plus 4, where x could be any real value. Now, why is the inverse of this function not possible? Well, it's a quadratic function, right? So you know it's a shape that looks like this. It's a quadratic function. And as you can see from the graph, it's not a one-to-one function. Inverse only exists for one-to-one function. So all you have to say here is, you'll say, because the inverse does not exist. Why? Because g of x, sorry, g inverse of x. Yep. So G inverse of x cannot be found. Why? Because g of x is not a one-to-one function. That's all you've got to write there. Since it's not a one-to-one function, and inverse only exists for one-to-one functions, that's why this inverse is not possible. Okay, and that will earn you that 1 mark there. Okay, so this drawing this graph is not necessary. You can just write the statement, and that's going to be enough. Okay. Okay, let's look at part E. Now it says, show that 1 plus 2 over 2x minus 1 can be expressed as 2x plus 1 over 2x minus 1, and hence find the area of the triangle enclosed by the tangent to the curve y equals f of x at the point where x equals 1 and the x and y axes. Okay, that's a 6-mark question. That means it is going to require some working. Let's look at the first thing here. So let's do this first. So it says, show that 1 plus 2 over 2x, 1 over 2 over 2x minus 1 can be expressed as that thing. Let's show that first. 1 plus 2 over 2x minus 1. We take LCM. That's going to give us 2x minus 1 plus 2 divided by 2x minus 1. We simplify this. That gives us 2x minus 1 and plus 2, which is 2x plus 1 divided by 2x minus 1. Okay, so that's what we have shown. That's the first thing that we have to do. Now, let's try to understand the second statement. It says, find the area of the triangle enclosed by the tangent to the curve f of x at the point where x equals 1. Let's think about that tangent first. So we have this curve here. So it says tangent to the curve at the point x equals 1. So x equals 1 is basically this point. And this is the point that we're talking about. Let's try to draw a rough tangent at this point. It may look something like this, right? So this is what the tangent might look like. Now it says area of the triangle enclosed by the tangent to the curve and the x and the y axis. Okay, so this tangent intersects the x and y axis somewhere. Let's just extend this bit, the y-axis. The tangent intersects the x and y axes, so it intersects it here. The y-axis, it intersects the x-axis here. We've got to find the area enclosed by these 3 lines, the tangent, the x, and the y-axis. So this is the triangle that we're talking about. This is the triangle that we're talking about. Okay, now how do you find the area of this triangle? It's a right angle triangle. So what we can do is we can just find this length here, and this length, and then you can use the formula half into base into height. But how do you find that? Find these lengths. You can find, so what you can do is you can find the equation of this tangent. Once you've got the equation of the tangent, you can find the x-intercept of that tangent and the y-intercept of that tangent, and you can use that to find the lengths of the triangle. Yeah, so let's do that. We find the equation of the tangent first, equation of the tangent to the curve at this point. That's what we're going to start from. What's the function? The curve's equation is 2x plus 1 over 2x minus 1. Let's write that down here first. F of x equals 2x plus 1 over 2x minus 1. So we are looking for the equation of the tangent to this curve at the point where x equals 1. Now, how do you find that? Equation of a tangent, you need two things for that. You need the gradient of the line, and you need a point on the line. Let's find the gradient first. How do you find the gradient? For the gradient of the curve at any point, you have to find the derivative of the curve, right? So we've got this curve. We need to differentiate it first. Now it's a fraction. It's a fraction which is 2x plus 1 divided by 2x minus 1. And in paper 1, we don't really know how to differentiate fractions, right? So if you've done paper 3 already, then you could actually use the quotient rule and do it that way. But if you're an ACE right now and you do not know the P3 differentiation concepts yet, you don't really know how to differentiate quotients, differentiate fractions. So what we can do here is we actually use this hint that they've given us in the first sentence here. And that is that 1 plus 2 over 2x minus 1 is the same thing as 2x plus 1 over 2x minus 1. So what we can do is we can write this function as 1 plus 2 over 2x minus 1. And now this is something that we know how to differentiate. Why? Because we can write this as 1 plus 2 into 2x minus 1 whole raised to power minus 1. And you can simply use the power rule here to differentiate. Let's do that. F dash of x, what is that going to be here? The derivative of 1 is 0. And the derivative of this expression, that's going to be 2 into the power, subtract 1 from the power, that's going to be minus 2, and then multiply by the derivative of what is inside the brackets, that's going to be 2. Let's simplify. We've got minus 4. And then we have 2x minus 1 whole raised to power minus 2. We can take that to the denominator. And that's going to be 2x minus 1 whole raised to power 2. That's the derivative. Now, we need the gradient of the curve at a particular point. At one point, it's basically when x equals 1. So what we can do is we can put x equals 1 here. And that's going to give us the gradient of the tangent. Right? Because this is the gradient of the curve at the point x equals 1. And that's the point at which we need the tangent. So that's also going to be the same. So what's that? That's minus 4 over 2 into 1 minus 1 whole squared. And if you evaluate this, this basically turns out to be minus 4. So this is the gradient of the tangent. How do you find the equation of the tangent? You have the gradient now. There's only one other thing that you need, and that is a point. You know the x coordinate of that point. That's x equals 1. How do you find the corresponding y coordinate? Let's figure that out here on the side. Let's find the corresponding y coordinate. We know x equals 1. Let's input x equals 1 here. And see what value of y we get, or f of x, that's the same thing. We get 2 into 1 plus 1 divided by 2 into 1 minus 1, and f of x turns out to be equal to 3 here, which is the same thing as y. So what's the point that we're talking about then? The point is 1 and 3. This is the point that we've got, and this is the gradient of the tangent. We have those two things. We can write down the equation of the tangent, and that's going to be, equation of the tangent is going to be y minus y1, that's y minus 3 equals m, which is minus 4 into x minus x1, which is x minus 1. So that's the equation. We can simplify this, and that's going to give us minus 4x plus 4 plus 3, and y equals minus 4x plus 7. This is the equation of the tangent. Now we want the x-intercept and the y-intercept. How do you find the x-intercept? You can put y equal to 0 for that. And how do you find the x-intercept? Y-intercept, sorry, you put x equals 0 for that. Let's do these two things and see what we get. So when you put y equals 0, we get minus 4x plus 7, and x equals 7 over 4 from this. And when we put x equals 0, we get y equals minus 4 into 0 plus 7, and y equals 7. Okay, so we've got the x-intercept of that tangent and the y-intercept. So they are 7 over 4 and 7 over 4 and 7 respectively. Let's actually write them down on the graph there. So this point here is 7 over 4. That's the base of this triangle, right? Because we're starting from the origin. And this point here is 7. Okay, so we've got the base of the triangle, we've got the height of the triangle. We can write down the area of the triangle using these two things. The area of the triangle, therefore, is going to be half into base into height. Area of triangle, that's equal to half into the base. Base was 7 over 4 into the height, which was 7. And that's going to give us something. Do we need an exact answer? It doesn't say so. So we're going to just write in decimals. Let's figure that out. That's 49 divided by 8, and that is 6.125. 6.125, and that is the area of the triangle that we were looking for. Okay, let's move to question number 11. So now we've got this function f that is given by 4 cos raised to power 4x plus cos square x minus k for x between 0 and 2 pi, and k is a constant. Now in the first part it says, given that k equals 3, find the exact value, find the exact solutions of the equation f of x equals 0. Okay, so in the first part, we just have to input the value of k equal to 3. So f of x equals 4 cos raised to power 4x plus cos square x minus 3. That's the function. And we have to find the exact solutions of this equation. So we have to put this function equal to 0, and we will get 4 cos raised to power 4x plus cos square x minus 3 from that. And now let's solve this equation. Now, if you have a look at this, it's actually an equation that can be written in a quadratic form. Why? Because we've got the powers in the ratio 2:1. This power is 4, this power is 2, so that's 2:1. What you do in these cases is that you put the smaller power equal to another variable. Let's say m equals cos square x. Then cos raised to power 4x is going to be m raised to power 2 or m squared. Okay, so we have a quadratic equation from this. That is 4m squared plus m minus 3. Let's see if we can factorize this. 4 and 3, that's 12. Yeah, so we could actually just use 4 and 3 for this. We have 4m squared plus 4m minus 3m minus 3, that equals 0. We get two factors from this, which are 4m minus 3, and we have m plus 1. These are the two factors that we get, which means m is either equal to 3 over 4 or m is equal to minus 1. So these are the two values that we get from this. Now, what was m? M was supposed to be cos square x. So that means cos square x is either equal to 3 over 4 or it's equal to minus 1. Now, of course, since it's cos square, a cos squared cannot be negative. It can't be minus 1. So this is not possible. We ignore this possibility. So the only possibility that we have now is that cos square x equals 3 over 4. So we take square root on both sides. Let's see what that gives us. Cos of x equals plus minus. Do not forget plus minus. Whenever we take a square root, we put plus minus. Square root of 3 over 2. That's what cos x turns out to be. Okay. Now it's plus minus. So that means we could be in any one of the 4 quadrants, because it could be both positive or negative. And cos, so basically this angle could be in any one of the 4 quadrants. Okay, so it could be anywhere. So let's find the basic angle. Let's find the basic angle first. Let's find the basic angle alpha. And then once we have that, we can write down 4 angles from that. Cos alpha equals square root of 3 over 2. Let's figure this out. Remember, we are using radians here. So your calculator should be in the correct mode. Cos inverse of square root of 3 divided by 2. Okay, so you can actually remember this value as well. This is actually one of the common values of cos, which corresponds to 30 degrees or pi over 6. But if you can't, you should have a calculator that gives you an exact result, because you do want exact answers here. So you should have a calculator that gives you exact values for this. In this case, I'm getting alpha equal to pi over 6. So I could either be here, this is pi over 6, right? Or I could have any one of these other angles. I could be here, it could be here, or it could be here. So I just have to write down these 4 values now, and that will be my values. Those will be my values for x here. So where do I start from? We've got x equals pi over 6. That's the value that we've got in the first quadrant. In the second quadrant is going to be pi minus pi over 6. And the third quadrant is going to be pi plus pi over 6. And in the fourth quadrant, it's going to be 2 pi minus pi over 6. Let's evaluate all of them. So the first one is pi over 6. We have that already. The second one is going to be 5 pi over 6. The third one is going to be 7 pi over 6. And the last one is going to be 11 pi over 6. So these are the values of x that we were looking for. All right, so that was 11 part A. Let's move on to the next one. Okay, let's move to part B. Now, this was a part that was actually found difficult by most candidates appearing for this paper. And there was a lot of confusion about this. Let's think about it. So it says, use the quadratic formula to show that when k is greater than 5, the equation f of x equals 0 has no solutions. All right. Now, it's not really apparent what exactly it means, or what should be the method that we use for this. However, what we can do is we can just follow the instruction that says use the quadratic formula. So let's try to do that, and hopefully we will get some idea from that. Okay, so let's start doing this. So it says this equation f of x equals 0. What's that function f of x first? We had that here. It was 4 cos raised to power 4x minus cos square x. No, it was plus cos square x minus 3 minus k, in fact. Just confirm that. Minus k, yes. So this was the function that we had. Now it says f of x equals 0. So we put that equal to 0. 4 cos raised to power 4x plus cos square x minus k equals 0. We've got to show that whenever the value of k is greater than 5, this equation has no solution. Okay, and we have to use the quadratic formula for this. Now, how is quadratic formula relevant? But it's because this can be written in quadratic form, just like we did it in the earlier part. We can say let another variable, let's say m equals cos square x, and that makes it a quadratic equation. Okay, and we are going to get m equals, or let's say 4m square plus m minus k equals 0. So this is the quadratic equation that we've got. Okay, now let's use the quadratic formula on this, because we can't really factorize. We don't know what the value of k is, so factorization is not possible. Let's use the quadratic formula as they have suggested. Minus b, so that's minus 1. Let me actually write ABC here as well for clarity. A is 4, B is 1, C is minus k. Let's just input values in the formula. Minus 1 plus minus square root of 1 squared minus 4 into minus k divided by 2 times 4. Okay, let's simplify this. If we simplify this, we get -1 plus minus square root of 1 minus 16 into minus k. That's going to be 1 plus 16k divided by 8. Okay, so that is what we are getting. So now there are two possibilities. There are two possibilities, and they are that m is either equal to -1 minus square root of 1 plus 16k divided by 8, or it's equal to -1 plus square root of 1 plus 16k divided by 8. These are the two possibilities that we've got. But now remember, what is m? M is cos square x. Let's put that back. So we say these are the two possible values of cos square x. Cos square is either equal to this or this. Now, the first value here, this is negative, right? Because we've got a negative number and another negative number. So the overall result is going to be negative. So this is not possible. So we ignore it right away. This is not possible at all. No matter what the value of k is, this is impossible. Why? Because if you have a positive number inside the square root, then this is negative, this whole thing is negative. This is negative, and the overall result is going to be negative. If you have a negative number inside the square root, then you are not going to get any real roots anyway, because you can't take a square root of a negative number. So that's not even possible. Okay. All right. Let's focus on the second option now. Now it says we have to show that when k is greater than 5, this equation has no solutions. Now let's see what is going to happen if k was greater than 5. Let's see what happens if k was greater than 5. Now, how do we think about this? We could say if k is greater than 5, and let's do it step by step. So if k was greater than 5, what about this expression inside? Or let's actually again break it down into a lot of smaller parts. If k is greater than 5, what about 16k? 16k is going to be greater than 16 into 5, which is going to be 80, right? What about 1 plus 16k? That's 1 plus 16k greater than 1 plus 80, which is 81. What about square root of this? What about square root of this? Square root of 1 plus 16k is going to be greater than square root of 81, which is 9. Okay, so it's fine until this point. But then we have this -1 outside. So we subtract -1 outside. So we've got -1 plus square root of 1 plus 16k. We do the same thing on the right side as well. -1 plus 9. What does that give us? That gives us 8. So we've got this greater than 8. And now if I were to divide this whole thing by 8, because we also have this 8 in the denominator, it becomes -1 plus square root of 1 plus 16k divided by 8. We do the same thing on the right side, 8 over 8. And that gives us 1. Okay, so now we've got exactly the same thing as before. Same thing as what we had here. If k is greater than 5, that implies that this whole expression that we've got here is going to be greater than 1, right? Now, what exactly does this expression on the left side represent? This represents cos square x, right? So if k is greater than 5, what that means is cos square x is going to be greater than 1. But is that possible? We know cos square x can only have values between 0 and 1. It can't have any value outside this range, right? If cos square is greater than 1, that means there's no value of x that's going to satisfy this. Okay, so what do we say here? We say if k is greater than 5, that gives us cos square of x greater than 1, and this thing is not possible. Now, since this is not possible, that means we are not going to have any solution here. All right, and that's what you have to prove here. We had to show that this has no solutions if k is greater than 5. All right, I hope that makes sense. So that was it. I think that's the last question that we have in the paper. Yes, that was question number 11. I hope you find this helpful. If you find this helpful, make sure that you have a look at the other content on the channel as well. And of course, you can share with others if you think they will find this helpful. I'll see you again in another video. Allah Hafiz.